So Bobby, what shall we do next?
So from common emitter, we went to difference amplifier.
Correct. We did so many things, no, in between. We first did common emitter amplifier. We first actually did biasing.
Correct.
Common emitter amplifier. We figured out how to add capacitance to, bias it properly and add the signal and DC.
Yes.
We removed the emitter resistor, added a current source, right? Then how to build that current source.
Correct.
Then we went to current mirror.
Yeah.
Then from the current mirror, we went to the differential amplifier.
Actually, amazing travel.
Yes, correct. Correct. It is like a bullet train going from, Bombay to Ahmedabad in 2 hours.
So everywhere it was common emitter.
Correct.
What about other configurations? I mean, we will only use emitter as common or?
Okay. I like that thought process. So what you're asking is the transistor actually has 3 terminals, no?
Correct.
So you're asking why we took this as common.
Yeah.
Right? Why common emitter? Yeah, we can do common base and common collector also. Why not?
Shall we try?
Let's try it out. So in fact, now I see automatically there are actually 3 amplifiers, no? So you can do common emitter amplifier. So in fact, it was called common emitter because we applied input on the base side with respect to the emitter, output on the collector side with respect to the emitter. So the emitter was common for input and output, right? So now that means that you can get
common base also.
Common base and common collector as well.
So all these are possible.
All of these are possible, and in fact, we have 3 terminals, no? So if you take common base, for example, you have to apply input on, collector and emitter. You have to choose one of them as input, one of them as output, and do it, right? And same way for the common collector also.
Okay.
Right? So maybe we'll choose the common base.
Yes.
So what I will do, shall I take the start with the transistor, right? So let us say I'll start with the transistor, and we want to apply the signal on one side. In this case, in the common base thing, we'll apply it on the emitter side, right? And take the output on the collector side.
Okay.
Because actually, let me draw the common emitter configuration first. We'll go from there.
Yeah.
Right? So originally what we did was, I'll just show the simplest picture that we looked at.
Yeah.
Right? We did something like this. This is what we did, no?
Yeah.
Simplest picture we did. I think we called it some VB or something like that, VDC, right? Now, that's why we said base is input, collector is output. Now, all we can do is, easiest way to do is swap the emitter and the base. Right? So, this was common emitter.
Oh, so then base will become common.
Base will become common.
Oh, as simple as that.
As simple as that.
Okay.
So, what we'll do, so now base will become common, and now collector we have to do this. Emitter we have to give the input. I think VDC, let me call it VDC, just to, we'll add the exact designations later. This is VI and this is VO, and that is all we have to do.
RC same. Yeah.
Right? RC is the same as before. Output is still taken at VO. Right? In fact, the analysis is so easy for this now. We did full analysis of the common emitter.
Correct.
Right? What did we do? I will just kind of, maybe we will go through the high level summary. I think what we did was, we wrote the expressions for VBE.
Correct.
We said it is VDC plus VI, and we wrote the expression, we said beta is very large.
Correct.
We wrote the expression for the collector or emitter current
Yeah.
as the full exponential.
Yes.
And what we did was we expanded the exponential,
True.
right? The first term gave us the DC value,
Correct.
right? So
Which we were not so interested.
we were not so interested. So all it gave was VCC minus IDC times RC.
Yeah.
And then it gave us the small signal portion.
Yes.
And I think that ended up being minus IDC by VT times RC times VI.
Yeah.
That was the first term.
Correct.
So we neglected the other terms like that. Now we can do the same thing for this, right? But I don't want to write down all that
Yeah.
mathematics.
So that means the second time we can straight away take if you are interested in this.
If you are
small
interested
signal
in
alone.
the small signal, correct.
Will it be minus or
Let us. So already I am seeing.
because here VB seems to be
Correct. So already it seems like VB earlier, VBE here. So let us maybe look at that. That will give us some direction. VBE was VDC plus VI minus 0 because emitter was at 0.
yeah.
In fact, here it is VBE. Okay, I need this color. Is actually mm, 0 minus VDC plus VI. Oh, it is the negative of the previous one,
Okay.
right? So earlier it was VDC plus VI. Here it is minus of VDC plus VI.
I have one doubt. Here this was forward bias.
Correct.
Now also
Correct.
Hmm?
Correct. It has to be forward biased for it to work properly,
Hmm.
which means it cannot be ground.
Yeah.
Correct.
Hmm.
So what we need to do is to
Raise it to a
some high enough voltage.
oh.
Perfect.
Oh.
Right. So we need to make sure that this VDC is such that it base emitter is forward biased.
Okay. Okay.
So which means we cannot tie it to 0. So shall we tie it to some higher VDC?
Yeah.
So in fact, we can just take this VDC and put it there.
That's also true.
That is okay, no? So in fact, that tells us something very important.
You are not changing the biasing.
I am not changing the biasing,
Only the
the signal, right? So let us do that. That is what I will do. I will do it like this. So I will connect VDC here and I will connect VI here.
So we started with saying base you will ground it.
Correct. Okay.
But I understand for the VI it is still ground.
That is correct because we are basically doing superposition
Correct.
between DC and AC.
Correct.
So now your VBE now is going to be VDC minus VI. And now for superposition, VDC is 0 when you are looking at VI.
Yeah.
So it is still common base. Technically still common base.
Okay.
So now what this
Because
tells
it
us
is minus VI
minus VI, we should expect
plus
GMRC times VI.
Okay.
Right? So in fact the DC value will remain the same.
Hmm.
So this is still VDC.
Yeah.
Corresponding to that I will still get IDC.
Yeah.
Right?
Yeah.
And the voltage here V0 will become VCC minus IDC RC,
Yes.
except now I have minus VI instead of plus VI. So now I should expect plus GMRC times VI. So earlier this was,
So it's not inverting.
it's not inverting. So this was GM.
Yeah.
I'll get the same GM except I'll get plus GMRC times VI. So in fact, this will be your small VO, which is the signal that we are interested in. So it is non-inverting amplifier. So the common base amplifier is a non-inverting amplifier. The gain seems to be magnitude wise seems to be the same as that you get
Correct.
here.
Because GM and RC
Correct.
is with us. I mean, we decide.
That's
GM,
right.
Once we decide the current, or now it is VDC.
Now it is VDC, but yeah, correct. We also did something with VDC. Instead of applying a voltage source,
We gave a current.
we gave a current.
Yeah.
Maybe that we can do that here as well.
Can be done.
Because you pointed out that the biasing is exactly the same.
Correct.
Shall we draw the circuit with that?
But I cannot just give that current in the base.
That is true. So what we did in the case of the common emitter was we did resistive divider and then put the current on the emitter side.
Correct.
We should be able to do the same thing here. Shall we try it?
We can.
So what I will do,
So now the base can be grounded.
now the base can be grounded. So this gives me the voltage that we want, VDC, and we wanted to add a current source,
Okay.
right? Same as we did before, some I naught.
But the VI,
So VI needs to be added, base also needs to be grounded, no?
yeah.
So, for common emitter amplifier, we added an RE here
And a CE.
and a CE. We should be able to do the same thing here, because now if we can just add a large capacitor CB here,
Oh, then for the signal that will be ground.
for the signal that will be ground.
Okay. And how to give the signal?
How to give the signal, correct. So
Without affecting the bias.
without affecting the bias,
Oh,
right?
that we have done earlier. In
That-
the other side.
On the other side, for the common emitter on the base side we did it, we'll do the same thing here.
Okay.
So I think we can just, we'll add I'll call this some CE. And now if you want to remove the DC, if you want only the signal, you can add some capacitance here as well. You will get this at the output.
So this means they are, I mean, common emitter and this are almost
Very similar,
Yeah.
very similar.
Yeah.
There are some small differences, but in terms of gain, they are very similar.
Yeah.
Right? So there are some differences, right? But so this is your classic common base. This is your common base amplifier. So now we have seen a second amplifier as well, except this is non-inverting.
Yeah.
But the considerations are very similar, no?
Correct.
You want a particular GM, so you will choose I naught. So the gain will be set by GM and RC. The bias point will be set by RC, R1 and R2, right? Relatively similar.